Hello friends, welcome to our channel Knowledge Amplifier. And in this particular video, I am going to discuss one very important and frequently asked interview question from linear regression, popular supervised machine learning algorithm. Okay, and that is what are the basic assumptions of linear regression, right? I am going to discuss all the major assumptions which you should keep in mind before applying linear regression algorithm in any particular use case. Okay, I will discuss with intuitive logics. You can easily remember that. I am not going deeper into the mathematical section for each assumption because it will be hard to remember, but if I discuss intuitively, then you will be having the feeling of the concept and you can explain the same in interview process also very easily, right? So the first very important assumption which I am going to discuss among 5 major assumptions of linear regression is basically there must be linear relationship between outcome variable and the independent variables. This is obvious, right? What we do in linear regression, any particular output value yi which we have to predict using regression, okay, which is one continuous value, is basically nothing but one constant term, suppose a naught plus what is that, a1 x1 is first independent feature, okay, then a2 x2 and so on, it will go up to an xn, right? So basically we are considering only linear relationship with respect to all the input features and output feature, right? We are not introducing such term where suppose maybe a n x1 square, okay, this kind of polynomial term will not come, right? Only polynomial with degree 1 will be maximum for linear regression. It is quite obvious. So linear relations should be present in between outcome variable and independent variables, and you can easily just verify this particular assumption if you draw the scatter plot for each independent variable and outcome variable. Suppose for here in this x-axis independent variable, here in the y-axis my outcome feature, our output value which we have to predict using regression is there, then if we plot we are getting this kind of curve. Okay, obviously this is not linear. Here y equal to x square type shape it is taking, right? So here in this case our linear regression will not work properly. So this is one of the very important assumption of a linear regression. Coming to assumption number 2, simple, already discussed with in-depth mathematical intuition, that is multicollinearity should not exist between regressors. Okay, if multicollinearity exists, then what will happen, as I have shown you using Python programming also, that with little change in one particular input feature there is a huge impact in the output, right? Assumption number 3, very important, the error term should have a population mean of 0. Okay, and see, this is very simple to interpret. Suppose this is my line. Now what you will, suppose here are my data sets like this, it is present. Okay, so what always my aim will be, if I try to fit one proper line which will fit in all this data, okay, then this particular gap, and this particular gap, whatever positive gap we have and whatever negative gap I have drawn wrong way, sorry, let me just erase this. This particular gap, this one, this one, this one and this one, okay, these are, this height is basically my errors, right? So obviously it is quite clear what we, how, if the model is perfect, then whatever positive error we are getting, that should be nullified by negative error, and as a result overall error term sum should be 0, and if sum of error is 0, then obviously mean should be 0, right? Like this you can understand intuitively, or I have already given you the mathematical derivation also why error term is 0. You can check my playlist for machine learning and data science using MATLAB, right? So this is assumption number 3. This particular picture, can you tell me based on assumption number 3 that is this a good linear regression model? Obviously no, because you can understand that, see, error term has population mean non-zero in this particular case, right? Because you can clearly understand that here in the positive error is much more than the negative error, negative side error. Negative side error values, that is these data points are very close to my actual fitted line, right? So the negative error will be less, but a huge positive error, right? So this is not a good linear regression model. So you can easily remember using this, that error terms should have a population mean of 0. Okay, this picture clearly explain the whole story. Then assumption number 4, observations of the error terms should have no relationship with each other. Okay, and this is also quite obvious. You can understand this is my regression line, suppose. Okay, and these are my data points. So if you just calculate the errors, okay, for each individual data point, you can hardly find any pattern in the errors, right? But suppose there is a beautiful pattern present in between errors. Suppose my data points are like this, then if you calculate the errors, it will, once it will go up, then down, then again it will increase and decrease like that. So beautiful pattern will be present in the error terms, right? But obviously we can understand intuitively that if error term has some pattern, that means that there is some information which is not captured by our machine learning model. That means obviously that is not a good model. Like here we can see that we can clearly understand that error term will be having relationship, and we can clearly see that this is not at all a good fit regression line, right? So in this type of case, when error terms have relationship, then we should think about some other algorithm might be, or we need to take some proper preventive steps, which I am going to discuss in my upcoming videos. Then assumption number 5, the error term should be homocydastic. Okay, what is means? It means that it should have constant variance. That means like this, if you consider this particular data here, this is my output y and input feature x of t may be income. Okay, and based on that, suppose we are predicting something. Now see, this this is scatter plot of my data set, and this is the line which is basically we are getting after applying linear regression, right? So you can understand, see, these are my errors, right? So these are my errors. You can plot for individual. So you can understand, as we are going in the positive direction, the variance of error or spread of the error is basically increasing, and this should not happen. Why? Because if this is the scenario, what this indicates, it is basically indicating some particular data are impacting our model more than other parts of my same data. Like here you can understand, in x of t, as we are going to positive direction, error increases. That means small value of, for small value of x, okay, that impacts our model more than the large values of x. That's why error is increasing at large values, right? But in machine learning, it should be unbiased model. The unbiased means all of the data points should affect equally, but here it is not happening. Here this is becoming biased with the small data of x. That's why it is giving less error for small values of x, but as the values of x increases, error increases. Okay, that is spread of the error increases, variance increases, right? Okay, and this also you should check before applying multiple linear regression or simple linear regression in a particular use case, right? So error term should have constant variance, homocydastic. Okay, and this curve is called heterocydastic. That means suppose I am having my data points like this. Okay, I can plot here, just roughly I am plotting. So what will happen, error terms will basically have a pattern like this. This is heteroscedastic data. Homoscedastic means, suppose I am just showing one use case. Suppose this is my line and this is my data, then you can see that error term has almost same spread throughout the range of my data, right? So this is homocydastic, and this also you should keep in mind that data should not be such that the error is coming heteroscedastic. Okay, there is constant variance should be present, right? So these are 5 major assumptions of linear regression. I hope you have understood this. So this is all for my this video. Thank you for watching.